So this video is about motion of the earth. There are three kinds of motions we're going to talk about. The first is rotation, which is the spin of the earth on its own axis. It takes 1 day for the earth to complete one rotation. Okay, that's how we define 1 day. The second type of motion is called revolution, which is the motion of the earth in orbit around the sun. So when the earth is moving around the sun, that kind of movement we call revolution. It takes 1 year for the earth to complete one revolution. That's how we define a year. The third motion is called precession. Precession is the slow top-like motion of the earth's axis rotation. It takes 26,000 years for the earth to complete one cycle of precession. So it's a very, very slow motion. Actually, during our lifetime, we probably don't even notice that. The first type of motion we're going to talk about is Earth's rotation. Because of Earth's rotation, so we're going to see apparent westward motion of the sun, moon, and stars across our sky each day. That's why we generalize this motion to be the sun rises in the east and sets in the west. So usually we know that the sun in the morning, the sun rises at some point along the eastern horizon and is going to move upward and then arc across the sky, and finally they're going to disappear somewhere along the western horizon. Remember, the definition of horizon we talk about in class is defined as the boundary between the earth and the sky. But not all stars in our sky rise and set. It depends on the different latitudes on the earth. So you can see here, okay, when in North Pole, you're going to see the stars moving like this, all horizontal. At equator, you're going to see vertical motion of the stars, and at the middle latitudes, and that's where usually people will see. There is a term here which is called circumpolar, and I believe the second lab you will be using this term. That is defined as those stars near the poles of a celestial sphere, the moving trails that circle the pole never set. So those stars that never go below the horizon, they're called circumpolar constellation or circumpolar stars. And I'm not going to ask you to understand this slide, so you can skip it. The second motion is revolution of the earth. Okay, so there are two important concepts I want you guys to know on this slide. The first one is called ecliptic. So what is an ecliptic? Ecliptic is, remember, in celestial sphere, okay, Earth is at the center, right? So then when Earth is the center, as if sun is moving around us, so that's relatively speaking. So from our perspective, the sun appears to move through the stars along a special path. This is called ecliptic. So you can see here, along this path, this is the annual path of the sun, okay? And we call it ecliptic. Because of the revolution, actually the sun appears to move slowly relative to the background stars over the course of a year. So this apparent motion of the sun on the sky traces out a path on the celestial sphere. We call it ecliptic. So that's the definition of ecliptic. And in this picture here, we define ecliptic plane. So what is an ecliptic plane? This is from an outside view, which means that, okay, now sun is at the center, earth is moving around the sun. We call revolution, right? And we see the earth revolve around the sun when defining the plane of the earth's orbit as the ecliptic plane. So this plane in which Earth is moving around the sun is defined as ecliptic plane. Okay, the ecliptic plane is important for us to understand the seasons in the next slide. Ecliptic plane forms a great circle on the celestial sphere inclined at an angle of about 23.5 degrees to the celestial equator. So you can see here, all right, so this is the vertical line here, and then that's the axis of the Earth. You can see there's a 23.5 degrees. Okay, so we call that the Earth's axis is tilted by 23.5 degrees. Okay, this tilt is a consequence of the indication of the Earth's rotation axis to its orbital plane, and because of this tilt, that's why when the Earth is revolving around the sun, okay, and the Earth is going to experience different seasons. So for instance, again, we are considering northern hemisphere because we are located in the northern hemisphere. So when the Earth is here, you can see this, the upper part here, actually in the northern part of the hemisphere is tilted away from the sun, but the southern hemisphere is towards the sun. So in this case, winter is in the northern hemisphere, summer is in the southern hemisphere. On the other hand, when the Earth is over here, you can see that the northern hemisphere is going to experience summer and the southern hemisphere is going to experience winter, okay, such as Australia. So this goes back to the celestial sphere model, okay, we learned before. Okay, again, Earth is at the center, and this is called ecliptic, which is the sun's annual path. Okay, this is called celestial equator. Okay, and there are 4 special spots along the path of the sun's annual path, which is called again ecliptic. Okay, the first point is called summer solstice. That is the point on Earth's orbit where our planet's North Pole is oriented closest to the sun, around June 21st. And when you look at this picture here, you can see the sun is moving actually to the highest point. When it reaches the highest point in the celestial sphere, we call this summer solstice. When summer solstice happens, it's going to be the longest day of the year. That means we experience the longest